So we've been talking about using the slope-intercept form for graphing and using this equations in slope-intercept form. And I had a student recently ask me, what about problems that aren't already written in slope-intercept form? So here's how I take a problem that is not written in slope-intercept form and rewrite it so that it's in the slope-intercept form. What I do is that I have my equation up here that I want to change, and right above it, I'm going to write the slope-intercept form. And when I do that, I want to make sure that my equal signs are lined up. So right above here, I'm going to write y equals mx plus b. So our equation, or excuse me, our equal signs are lined up. And then I basically just start asking myself, okay, I have a negative 2x. Is that negative 2x on the correct side of the equal sign? Say, no, it's supposed to be over here. It's supposed to be where the mx is at. So what I do at this point is I'm just going to move this over there. I'm going to get rid of this negative 2x. We're going to use the opposite operation or inverse operation. And the way we do that, get rid of a minus 2x, we're going to add 2x to both sides of the equation. What's going to happen is we'll have 3y that remains on that side of the problem. And over here, we're going to have our 2x minus 12. Now, as you remember, we cannot add 2x or we cannot subtract these two things together because they don't have the same variable. They are not like terms. Okay. Now, we're almost in slope-intercept form, but now we ask ourselves, I'm supposed to have just a y here. So I need to get rid of that 3 to make it look like the y equals mx plus b. So how do I get rid of the 3? Well, we're going to have to, it's connected to the y by multiplication, so we're going to use the inverse operation. We're going to use division to get rid of it. So we're going to divide by 3, and then over here we're going to divide everything on this side of the problem by 3. So then what we'll be left with is y equals 2/3 x minus 4. So we've taken this equation right here, we've taken negative 2x plus 3y equals negative 12, and we've rewritten it into the slope-intercept form, and now the same equation is written as y equals 2/3 x minus 4. Let's take a look at another example. Next example, it's similar to the first one, but now we have a 2 on the outside. Now there are a couple of different ways to attack this, but first of all, we're going to have to write y equals mx plus b. There's a couple of different ways we can deal with this 2 over here, but a lot of textbooks are pretty straightforward that we're going to take this 2 and we're going to distribute this 2 to everything that's inside the parentheses. So now we're going to have 24x minus 8y equals 16. And then we're back to the same question of, I'm going to move this down here. I'm just going to write y equals mx plus b again, top there. So we ask ourselves, I got 24x here. Is that 24x on the correct side of the equation? Say, no, it's supposed to be over here where the mx is at. So we get rid of a positive 24x. We're going to get rid of it by minusing 24x from both sides. Scroll down a little bit. What we'll be left with is a negative 8y equals negative 24x plus 16. A spot that a lot of my students will make mistakes with is forgetting to drop this negative down. So we look at this, so it's subtract 8y or minus 8y, but it's the same thing as a negative 8y. So we want to make sure to include that negative, super important. Now we ask ourselves again, okay, so we're almost at y equals mx plus b, but what do we have to move? What do we have to get rid of? We can't have that negative 8 there. How is that negative 8 connected to the y? Well, it's connected by multiplication. It says negative 8 times y. So the way we get rid of that is we're going to divide. So we're going to divide this by negative 8, And then we come over here and we divide everything on this side of the problem by -8 as well. What we will be left with is y equals 3x minus 2. And once again, y equals 3x minus 2. That's in slope-intercept form. Our slope is the 3. Our y-intercept is -2. And it is exactly the same equation as what we started with. It's just rewritten in a different format. Okay. And finally, let's take care of one more example. Now, something like this is going to show up quite often when we're talking about graphing linear equations. So, once again, we have some distributive properties. So what I would do is let's go ahead and distribute 5/3 to everything that's inside the parentheses. So 5/3 times x, I'm just going to write it as 5/3 x. 5/3 times -9 is going to be a -15. And over here we have y minus 4. So now, once again, let me drop this just a little bit. Right above this, I'm going to write the way that I want this equation to look. I want it written in slope-intercept form. So I'm going to write y equals mx plus b. And again, our equal signs are lined up. Then I come over here and I just start at the left-hand side again and I say, I've got a y right there. Is that y where it's supposed to be? Yeah, I want the y to be on the left side of the problem. Okay, cool. So we don't do anything with the y. Now I have a -4. Am I supposed to have a -4 on that side? No. We're not supposed to have anything over on this side except the y. So how do we get rid of a -4? Well, we're going to go ahead and add 4. So plus 4, and then we're going to come over here, and we're only going to add the 4 to the -15 because these are the only like terms. We can't add 4 to a 5/3 x because they're not like terms. They do not have the same variable. So now we're left with y equals 5/3 x minus 11. And this equation up here, y minus 4 equals 5/3 times x minus 9, is exactly the same equation, or exactly the same line as this one down here, y equals 5/3 x minus 11. It's just written in a different format. So now you can take any equation, well, there's 3 examples that we've done here, but we can take any equation and we can rewrite it into slope-intercept form.